It's a mathematical technique to show 2D or 3D coordinates with an added coordinate. Okay, added coordinate W. Okay, so to do what? To elevate it into a uh, higher, not higher dimension projection projection space. Okay, so why do we do that? So there are few reasons I would now tell you. First reason is, so what our GPU does is, GPU or your graphic cards they are best at doing, okay, they're best at doing matrix multiplications repeatedly. Okay, repeatedly. Yo, what's up? Welcome to the stream. One person came up to the stream, bro. Thanks for coming. Welcome to the stream, bro. Really appreciate your visit. So what I was discussing was, uh, so our GPU are best at doing, our graphic cards are best at doing matrix multiplication repeatedly. So, what do we transform in shapes is, what do we transform in shape is, we do scaling. Okay, scaling is uh, zooming in or out of image. Okay, like enlarge or shrink the image out of image. What does rotation do? We do rotation too. Okay, now what is rotation? Rotation is uh, like spinning the image. Then we do another thing which is called uh, scaling done, rotation done. Then we do translation. There is also other things like shear, like changing perspective and all, but they are very higher, they are higher advanced techniques. Okay, basics are these. Okay, so what do we do in translation is, we uh, move the object to a distance. Okay, now what happens here is there are some problems. There is a scaling, translation, rotation. So I would show you 2D matrix of everything. So what is scaling 2D matrix? It is x comma y multiplied by scale factor, right? So it is sx sy. So you just have to multiply it with scaling factor. Or let's say, you see this? Okay. Now what you have to do is rotation. So, so my marker is dying again. So I have to change my marker. So now what I have is I have rotation. So in rotation, I have cos theta minus sine theta, cos theta. You just have to like invert the positions, and like you have to do derivative of cos theta is minus sine theta, derivative of sine theta is cos theta, like that. You can do like that too, or you can just remember that in diagonals same things are there with opposite signs, or but cos, it is an even function, so there is no negative sign. Sine is the odd function, so there is a negative sign in the diagonal stuff. Okay. And in rotation, what we do is you have to write this and x and y. But what happens in translation, since scaling is enlarging of a stuff, so what do? We just multiply the scaling factor because it is multiplying. Here also rotation cos theta sin theta. Hriday Kalbhor 5920 says, please don't. What did I do that you are saying please don't? What did I do? Like, did I do something wrong? Okay, I'm really sorry if I did something wrong. So yeah, rotation, and rotation what happens is we have to tilt it with an angle, so that we have to multiply here. Okay. Now what happens in translation? In translation, what we do is x, y, and we add translation factor, because what is happening here is in translation you are moving an object, so we have to add that distance. Let's say he is a object, I have to make him walk this much distance, which is tx, so I have to add it, right, this distance, then it would move, right? So that's what happens. But in stretching of an object, I have to stretch it, so I have to multiply to all sides of it, then only it will stretch, right? So like that. But the problem is my GPU can do, like any GPU or graphic card can do scaling and rotation, but these are the transformations, like all three should have happened together. So now the problem is what would happen here is, so composite should be translation multiplied by rotation multiplied by scaling. But here you can't do that because my GPU would be going crazy on this operation, because this is addition operation which most graphic cards can't do. So what we do here is just add a dimension, add w dimension. Now what happens here is, so let's say 2D, in 2D what happens, it is x, y and w. In let's say 3D, what happens here is x, y, z, w. And to make it real world coordinates, what we do is divide it whole by divide it whole by w, divide whole by w. Then what happens is it is either x by w, y by w. Oh sorry, wait a second. Y by w and 1. So when it is 1, so it becomes real coordinates. And I would show you this one too, x by w, y by w and z by w. And this is 1. So these are real coordinates, real world coordinates. Okay. So now what happens is, now my translation becomes, so only defective thing was this, so I corrected this. Now what it happens here is, so what it would be become is, since I have used, let's apply this on 2D transition. Okay, x y1, then I have, okay, uh, tx 1 0 tx, then it would be like it is, you know uh, this matrix would be, uh, uh, so this matrix would be identity matrix, like all diagonal elements would be one unit matrix, but instead of here 0, these both parts would be ty and tx, which is translation factor. Now what would happen when I solve this, it would be still addition. Okay, so this becomes matrix multiplication. Okay, now what happens is here to, so what do we do in matrix multiplication? We multiply this row to this column and add it. Okay, let's do this. Okay, so this is x or multiplied by 1 x. So what we do here is we multiply corresponding elements of row and column. Okay, so wait a second. Yes, so we multiply corresponding row and columns, like first row to first column, each elements, a11 to a11, a12 to a21, like that, like opposite elements, like row column but same place, like first second third, that is same. Okay, so 1 into x x, then 0 into y, obviously 0, plus tx into 1 is tx, and let's do the same for y. Now what happens here? Y into 0 is 0, sorry, wait a second, sorry, x into 0 is 0, y into 1 is y plus y, then 1 into ty becomes ty, and obviously this would be, like 0 into x is 0, y into 0 is 0, 1 and 1 into 1 is 1, so this would be 1. So when I like take matrix multiplication of this, so this is becoming addition, and this was exact thing what happens here too, like it is what it is, x. So in addition what we do, we just add corresponding elements, x plus tx and x plus ty. That's what happens, right? So I have solved this problem. Now this is also matrix multiplication, and obviously these would also change in matrix multiplication. So that won't be a problem right now. Okay. So now what happens here is, also there is another benefit that you can represent infinity with this. Uh, how I can show you? Represent infinity. So how to represent infinity? I would just take x, y, and this w I can take as 0. So what happens here is, to make it real world coordinates, I would divide by 0, and this would be divided by 0 to make this 1. So in turn, anything divided by 0 is infinity. So I can solve for infinity like this. Normally I couldn't have solved in graphic card, I couldn't have solved infinity because infinity is not a number. Okay, now this looks like perspective. We use this in perspective projection. Like image coming from infinity. Okay, so this is how it happens. Okay, so if I take the 0, I have to divide all 0 to make this 1, to make it real world coordinates. Third should be 1, so others become infinity. Okay, now this is used in perspective projection, which is coming from infinity in one dimension, from a dimension. Okay, so I have solved this problem. Okay, so that by adding a dimension. So that's how you solve the problem, by adding a dimension. So that's what homogeneous coordinates do. So take screenshot, take notes. Like, share, subscribe. See you next time. Bye.